So today we are going to do solving quadratics, and there are a bunch of different ways that you can do this. There are a lot of different methods. What you want to do is get good at looking at a problem and thinking, okay, what's the best method going to be? Because you want to work smarter, not harder. Now, in order to do this, we're going to have to review our perfect squares. And yes, as was it just brought up to me, I have a typo there. They should be perfect squares, not prefix squares. It didn't red underline that for me because prefix a word, so I didn't catch that. I'm terribly sorry. But let's just go through and see if you know these. People forget about 1. Don't forget about 1. I get why it happens. It's because 1 squared is 1, but just don't forget about that one, okay? And I just want to see if you guys can shout these out to me. What's the next one? 4. Good. All right. You have to say them slow enough that we can all write them. 49, good. 8 and 8, now stick on the floor. 81. 100. 121. 144. If you know them further, that's super awesome. I require up to 12. Okay. The idea is that when you square root those, you undo what we just did. So for example, what's the square root of 81? 9. Like you're doing that backwards. Okay. Now we're going to briefly talk about imaginary numbers. Your imaginary number is I. Make sure that you dot it very deliberately. I can't talk. Very deliberately. That is the square root of -1. It's just how you get a negative under a square root. You're technically not allowed to square root negatives. So mathematicians like invented their way around it. Yeah, so like if you have a negative under there, you're just going to put I because it's imaginary. So like look at this one. Hey guys, let me cover up the negative for a second. What's the square root of 100? 10, but because there's a negative there, it will be 10I. Listen, it doesn't make your answer negative. It makes your answer imaginary. I love imaginary numbers in a way though, because what other class do you like imagine? Like it's not even real. Like we just invented it. It's crazy. That's cool. You can disagree, but I'm right. All right, now these ones aren't perfect squares, so we're gonna have to split them apart. Here's what you do first. Take out the part that's negative. We're gonna take out an I. Sounds really violent. We're gonna take out an I, and then what you need to do is split up the 8. Draw 2 little houses. You need to, and we'll see what you remember from last year. You need to come up with 2 numbers that multiply together to equal 8. One of them has to work. It has to be one of these. So one of them's got to work. Good. 4 and 2. 2 and 4, whatever order you want to put it in. What I get all the time is people want both of them to work. That's not going to happen. Just one of them. And the idea is you simplify as much as you can. And then what's left over is like, we did good enough. Okay. So what is the square root of 4? That's why we picked it. 2. This part would be good, I, and then square root of 2 is the leftovers. You're going to have one that works and one that's just, well, we did good enough. We tried, exactly. Good enough is like my motto. You did good enough. If you didn't get that, we're going to do another one. First thing you do is take out an I. I know it sounds really violent. Take out the imaginary part. You can do that if you want. I don't draw branches. I don't draw like a tree. I don't draw trees. I'm sorry. Whatever method works for you though. Okay. Hey guys. We need 2 numbers that multiply to be 48. One of them's got to work. Now hold on. Because 4 times 12, 4 will work, but we want one that's bigger. You want the biggest one possible. Like we did our best. 16 times 3. No. It's a verbal direction. So what is your square root of 16? That's 4. This part is I, and then square root of 3 is like, well, we did our best. Square root of 3 just got left over. What's that? Yeah, well, there you go. It's a good motto to have. All right, so take out an I. And then we need 2 numbers that multiply together to be 45. One of them, 9 and 5, good. So your square root of 9 is 3. This part's I. Square root of 5 is left over. Hey, kiddos, that is the extent of what we're doing with imaginary numbers. Do you remember last year when you had to add and subtract them and you had to do like I to the 59th and stuff like that? Yes. They took that out of the curriculum. That changed last year. That's all you got to be able to do. So basically, when you square root a negative, you just need to know it's imaginary. That's really it. And you have to be able to split up some of them. Okay. Now we're going to get into solving these. There are so many different methods for how to do these. I'm going to show you each of them. And then what you want to do is be able to look at a problem and decide what the best method is going to be. You're probably not going to really ever solve by graphing, but I'm going to show you at least one so that you can understand what it is we're doing. The visual helps. So we're going to solve this one by graphing. It's a parabola. Okay, that's the unit that we're in. How did it get shifted? Like up, down, left, right. Good. Go up 8, put a point. That's actually right at the very top. I think all those grids I have are 8 by 8. All right, now we're going to plug in some numbers on either side. So like, let's try 1. Ready? 1 squared. 1 times -2, -2 plus 8, 6. So you get 1, 6. And then because symmetry, you get -1, 6. Maybe symmetric. Remember axis of symmetry? Okay, now let's try 2. 2 squared. 4 times -2, -8 plus 8, 0. So you get 2, 0 and -2, 0. So here is our parabola. And when you solve by graphing, you literally just look at it and go, there's the answer. That's it. Okay. So where does this graph touch the x-axis? There's 2 of them. Good. And you can write them as ordered pairs. When we're solving, we just write them as solutions. So we would actually just say x equals -2 and x equals +2. If you wrote them as intercepts, I would obviously accept that as well. But do you see how it's an equation, like equals 0? Anyway, that's what graphing is. I like to show you at least one. I know you would probably never choose that method, but I want you to understand what we're finding, and it's the x-intercepts. Now, I know this next one is causing like anxiety already, okay? Factoring is an assumed skill in this class. Here's what I am going to do for you, though, since you guys indicated to me that you were real nervous about it. Here's what I want you to do. Set down your pencil and just watch. I want 100% of your attention. I'm going to do a real quick review of factoring. If you are like, hey, but I want these written down, there's not space on here. I'm going to take a picture of this and post it to Schoology with the notes. I will do a real brief review of factoring for you because I care about you and I want you to be successful. All right, what you're doing is FOIL in reverse. You're trying to break it apart instead of put it together. So I'm going to draw my 2 sets of parentheses. You remember this, sort of? You don't even remember the parentheses?
No, I remember.
Okay. X squared will split into what? X times X. Now you need to split up 10. So you have to come up with numbers that multiply together to be 10, but add or subtract to be 7. 5 and 2. Now I do the symbols, pluses and minuses last. Mathematics can be overwhelming when you try to do everything at once. So do one thing at a time. We decided 5 and 2. Great. Now how do I make them be a +7? You add them. That's it. Let's try that again. 3x squared minus 3x minus 36. What goes into all of those that you notice? You have to be a good noticer. 3. I'm going to take out a 3. You're just undistributing. This is GCF. Done that for a long time. Divide out a 3. What's going to be left? Minus x. And you can put a 1 in front. Here, I will do that. We'll put a 1 in front of that. Minus. We got there. We got there. It took us a second, but we got there. All right, now the 3 is just hanging out. Now this problem is exactly like question 1. I'm just going to split it apart. X squared will be x times x. Now you need numbers. Do I need to fill out that form to have that taken away from you? Put it in a backpack. I don't want to see it again. If I do see it again, it will be taken. I need numbers that multiply together to be 12. But add or subtract to be 1. But Miss Cole, it's a -1. Don't care. Worry about the symbols last. Be 4 and 3. Once you decide that, then do the symbols. How would I make these give us a -1? -4 plus 3 will give you -1. Are you with me on that? I should see your eyes and heads nodding. Okay. Yes, you could write 3x plus 3x minus 4. That would mean the exact same thing. No, you cannot switch those. Let's talk about that because that's a good question. Why would this not mean the same thing? Because 4 and -3 would give you a +1 here. So you can't do that. I'm so glad you brought that up there because that was a really good conversation for us to have. All right, do you see how these are missing the middle term? There's no x's. So that means it's 0x. So if you want to think of it like what we just did, this middle term is nothing. Get your head up. So what you're going to do is treat it like there's a 0x in the middle. So you're going to do it the exact same way. You just want it to add and subtract to be nothing. So it would be x and x, and then how would we split up 9? Good, and you guys even got the symbols in there, plus and minus. If you put the minus there and the plus there, that's fine. Oh, go ahead. Oh, I made them both plus because I'm talking the same time. There we go. If you put the minus there and the plus there, it would mean the same thing. Does anyone remember what that's called? Like what these are called? Because there's a special name for them. It's something squares. It is a difference of squares, is what that's called. So same with this one. How would you split up 4x squared? 2. Good, because 2 times 2 is 4, and then 25, 5 times 5, and then to get nothing in the middle, plus and minus, or minus and plus. Okay? Now these ones are the tougher ones because you might not guess right on the first try, and that is okay. We need numbers that multiply together to be 8. Let's try 4 and 2. If we're wrong, we will do try again. Okay? What numbers multiply to be 5? Do you want to put the 1 in the first parenthesis, or do you want to put the 1 in the second parenthesis? You really just have to make a decision and try it. First. Okay, let's see what happens. What are the outsides given us? 20x, good. And the insides? 2. Will 20 and 2 add or subtract to be 6? No. Let's try again. What do you want to do? Maybe flip around the 1 and the 5? Was that a big deal? It was not a big deal. We're going to try again. Now what do the outsides give us? What do the insides give us? Will 10 and 4 add and subtract to be 6? Now we're going to worry about the symbols. Save that to last. If you want a -6, you would need a -10. So that's going to go here. -5 times 2 would give you -10. And then a +4. 4 times +1 will give you +4. And then this is your answer. You just might not guess right on the first try, and that's okay. Let's try one more. How do you want to split up 4? You can do 1 times 4 or 2 times 2. 2 and 2. How about 18? There's a lot of choices there. Let's list them out. You could do 9 times 2, 3 times 6. I guess that's not, well, it's probably not 1 and 18. You know what I mean? Like you start multiplying by 18, that's going to make things ridiculous. So what do you want to try? What are the outsides given us? How about the insides? Will those add or subtract to be 21? What do you want to do? Well, flipping them won't matter because these are both 2s. Same thing. 2 and 9. All right, what are the outsides given us? Will 18 and 4 make 21? What do we want to try now? Okay, so 2 and 2 didn't work. We're going to try 4 and 1. What do you want to try from over here now? Now the order actually does make a difference because these aren't the same thing. 3 and 6? You want the 3 here? Okay, let's see what happens. Outsides are giving us what? 24. Insides? Will those add or subtract to be 21? Oh! Okay, now worry about the symbols. You want it to be a -21. -24, that means the negative goes here and then +3. You just might not guess right on the first try. You just have to do try again and listen to me when I'm trying to explain stuff to you. Let's go back to your note. Solve by factoring. Means you're going to factor it and then get your answers. You're going to do what we just did over there, but then keep going and get your answers. Here's the thing. It has to equal 0. Evacuate. Get everybody to one side so it all equals 0. How would we do that here? Add your 4x. Now be clever about where you write it. Where should you put the +4x? The beginning. It'll be 4x squared minus 9x plus 2 equals 0. And then we're going to factor it. We might not guess right on the first try, and that's okay. Just don't write with pen. How do you want to split up the 4x squared? We're going to do 2 and 2. And then the 2 at the end? 2 and 1. Now, I'm not going to draw in the little rainbows because I don't want to mess up this paper. What are the outsides going to give us? 2x insides 2 plus 4 is sadly not 9. What do we want to try?
Maybe 4 and 1.
4 and 1. All right, let's do that. Was that a big deal? No, you just got to try again. That's it. Now this is going to be 2 and 1. It does matter where we put them though. Where do you want to put the 2? Do you want the 2 in the first parenthesis or the second one? Second one. Okay. And do you see how the more you practice this, the better you will get at guessing right, like sooner? Like the more you do it, it's building your number sense. Now what do the outsides give us? 8 insides. Oh my gosh, 8 and 1 makes 9. Now we want it to be negative. Yeah, they'll have to both be negative, right? Negative 8 and negative 1 makes negative 9. Do you see how this is a positive 2 right there? Why did that happen? Yeah, negatives cancel. Negative 1 times, if you did FOIL, first, outside, inside, last to this, you would get what we started with. You just anti-FOILed. Now, what you're going to do is get your answers. Don't forget to follow through, because what happens is I get people that factor and then don't get any answers. I'm like, you want to set those equal to 0. Let's start with this one because it's easier. If you set x minus 2 equal to 0, what would you get? 2. Now, this one would be a 2-step problem. I want to like start coaching you to do that in your head, though, so you're not writing out all these steps. You would have to add over the 1, divide by 4. Good. So 1/4. So just don't forget to get answers. That's fine. And every method is valid. But like once you get to upper level math, you have to be able to factor fairly quickly without doing like 10 zillion steps. So you want to get good at guess and check, because the more you build up your number sense, I promise you, you'll start guessing quicker every time. Like it'll only take you 1 or 2 guesses. Okay. How is this one going to split? How are we going to split up 16? 4 and 4. Do you notice 16 and 49 are both perfect? Good. You want to be a good noticer. So 49 is going to split 7 and 7. You'll get plus and minus because there's no x's in the middle. See how it's like 0x in the middle, like it's missing? Now, don't forget to follow through and actually get your answers. This one, you would subtract 7, so it would be a negative 7, and then divide. Good, so negative 7 over 4. And then the other one would be positive 7 over 4. We'll do a couple more and then I'll give you a break. These ones say use the square root property. Here's the square root property. Are y'all listening? When you square root something, what do you put in front of it? That's if you square root a negative. But if you just square root a number, plus and minus, let's talk about why that happens. Let me just write it off to the side here. Give me a little number, like a single digit number, 2. If you square 2, what do you get? 4. If you square negative 2, what do you get? 4. So when you go backwards and you square root 4, how do you know if it was the positive or the negative 2? Do you get what I'm saying? They both work? Okay. When you square root, put a plus and minus. That's the square root property. Other than that, it's just solve the equation. This 5 is being multiplied. How do you undo multiplication? Well, we can't distribute in there because this is squared. We're going to divide by 5 on both sides. This is just welcome back to solving equations. You with me here? Yeah. Okay. It'll give you x plus 2 squared equals 6. Good. Let me get another color here. To get rid of the squared, we will square root. And whenever you put a square root, you have to put plus and minus. So this will be x plus 2 equals plus and minus square root of 6. Don't discriminate. Square root of 6 is a great number. I don't know what that is without a calculator because 6 isn't a perfect square, but you're going to just do nothing. We love doing nothing, right? Like that's great. All right, and then your last step would be what? Now, here's the thing. Don't write this because you would have that minus 2. You don't want to write it that way because can you see a potential issue? Like if you drew this bar too long, it would look like it's underneath. So instead, you want to do this. Put it in front. When you subtract the 2, put it in front of the plus and minus square root of 6. You will get used to doing that because that's the format like all your answers are going to take. But when you subtract over the 2, just put it in front because if you stick it at the end, it could look like it's underneath the square root. So when you square root, put a plus minus. I'm gonna say that like a zillion times. When you square root, put plus minus. All right, let's try one more. What would you do with the plus 64? Subtract 64. Again, this is just back to solving equations. Make your algebra teachers proud. All right, and then divide 2. So that'll be negative 32. And then square root. So it'll be x equals plus and minus. Now, when we did square root of 6, that's just square root of 6. That's not a big enough number to split. 32 is going to split, though. That's why I had us do some of these practice ones up here. We're going to split it just like we did those ones. So the first thing you take out is, take out an I. I know it sounds violent. Take out an I. And then we want to split 32. 4 will work, but you want something bigger. You want the biggest one that's bigger. 16 times 2. What's that? 16?
Well, I mean, I'm not gonna know this. 16 times 2.
You'll get better at it. It comes with practice. All right, so your final answer will be plus and minus. What is your square root of 16? 4. This part's I square root of 2. So listen, your answers were imaginary. So if you actually graphed it, would it touch the x-axis? Like, would you have answers you could actually see? No, because they're imaginary. Cool, cool. So this says solve by completing the square. We did that last class. Let's review. You take the middle number and you do what to it? There's 2 things. Divide by 2 and square. Good. Okay. First thing is we need to evacuate. Make it all equal 0. So I'm going to subtract over the 2x. Where should I put it? Yeah, after the x squared. X squared minus 2x plus 10 equals 0. You really want, that's like your starting place. Because what you're finding are the zeros, the x-intercepts. So you start with it equaling 0. All right. So now we're going to write x squared minus 2x. Leave a gap because we're going to put another number there, but we don't want it to be 10. I'm going to subtract the 10 to the other side, and I'm going to use another color. And it won't show up very well up here, but I'm going to do my best. So you're going to take 2, divide by 2 and square. That would give you what? 1. 1 can be tricky. People forget about 1. I'm writing too large today. This is like encroaching on my other space. I'm sorry. So the whole point is now you can write it as something squared. Write it as blank squared. What goes in the blank? X. Minus, good, because it's going to match whatever's here. What? 1 squared is 1. Equals, and then what do we have on this side? Negative 9. Now it is exactly like questions 4 and 5. Okay, so how do I get rid of the squared? Whenever you put a square root, you have to plus and minus. And good news, 9 is a perfect square, so that won't be too difficult. Square root of 9 is 3, but since it's negative, it'll be 3i. Good. And then your last step is to add 1. Again, you typically see that written out front. It would be 1 plus and minus 3i. If you wrote plus and minus 3i plus 1, I wouldn't mark it wrong. It's just, and you'll get used to this because we're going to just be solving a ton of these this unit. That's just typically the format that you see it in. I'm sorry I wrote too big. I apologize. All right, this one has a 3 out front. The first step is you're going to have to factor out the 3, but only from the first 2, right? It won't go into 7 anyhow, okay? So when you factor out 3, that's going to leave you with x squared plus, good, thank you. The most common mistake I get on the test is people will put that 3 out front, write x squared, and then still write 12x, like not do anything to it. And someone will do it, just please don't let it be you, okay? Now we're going to complete the square. What would, well, here, let me set up the rest of this. You're going to leave a gap there for us to like fill it in. So you're going to divide by 2 and square. 4 is a little weird because if you divide it by 2 and square, you get 4. And that happens because 2 plus 2 is 4 and 2 squared is 4. That's just kind of, I mean, how it works. Now, We didn't really add a 4. We really added a 3 times 4. So you're going to add 12 to the other side. I know that's a confusing step. Just remember, if you have that number out front, all you do is multiply those together. That's all it is. 3 times 4 is 12. That's what you add over there. So the whole point is so that you could write it as something squared. So what would go in that blank? X plus 2, good. And then over here, 7 plus 12, 19. And now it's exactly like questions 4 and 5. You would divide by 3. 19 doesn't divide nicely by 3, so you will leave it as 19 thirds. I was helping my son with his math homework, and he's like, that's an improper fraction. And I was like, so? And he was like very upset about it. Like, nope, we leave them like that. All right, then get rid of the squared. Square root. Whenever you put a square root, you have to put a plus and minus. So guess what? It's going to be plus and minus square root of 19 thirds, because there ain't anything we can do with that. I'm not touching that one. 19 is prime anyway. So is 3. There's nothing we can do. And then your last step would be subtract 2, but where should we write it? In front. So it'll be negative 2 plus and minus square root of 19 thirds, which is a great answer. And actually, it's not just one answer. It's really, let's make sure you understand that, because that's actually huge. One answer is negative 2 plus square root of 19 thirds. And then the second answer is negative 2 minus. So like, do you get that there's 2 of them? Like when we graphed this? Just making sure. Oh, they had you write both of them? I don't make you do that, but I'm glad that they did, because that really hammers home that there's 2 answers. All right, now if none of those methods work, like if you throw everything at it and completing the square is just going to be really difficult and it's not set up in a way that's going to work, your like last ditch effort, this is like your Hail Mary, is the quadratic formula, okay? It is x equals negative b plus minus, I don't allow whining, you see that sign up there? Square root, does anybody remember it? I hear some of you saying it. B squared 4ac, good, and then that's all over 2a. You're really like, so a is 2, b is 4, c is 3. It's not a bad formula. I mean, like people get scared because it's a little long, but you really just plug everything in and then get your answers. Easy. I love it. All right, so x equals negative b, that would be negative 4 plus minus gigantic square root. All right, b squared, that would be 4 squared, which would be 16, good, minus 4 times a times c. So that would be 4 times 2 times 3. Let's see, 4 times 2 would be 8, times 3 would be 24. 4 times 2 is 8, 8 times 3 is 24. Over 2a, 2 times 2 would be 4. And then essentially you just simplify that down. It'll be negative 4 plus and minus. Oh, this is going to come out negative though. That would be square root of negative 8. Good. And so we're going to have to split that up. It'll be, but before the 2 and the 4, you have to take out an I and then 2 and 4. So it'll be negative 4 plus and minus. All right, the whole point of splitting this apart is you can reduce some of it. It's like we're doing our best. Square root of 4 is 2. This part is I. Square root of 2 over 4. And if we're being super thorough, what you're supposed to do, here I'll use another color. And I always draw this, it looks kind of like a heart. Like you take the first part over 4 and then the second part over 4. So it's separated by that. Do you remember doing that last year? Okay, so you're like upset about that. The reason why is you're supposed to separate the real part from the imaginary part is the reason behind that. That's why we're supposed to do that. So negative 4 over 4, I mean negative 1 plus and minus. And then here you have 2 over 4 that would reduce to 1/2. And then I square root of 2. I would argue that this looks worse than that. personally. But again, the point is that you're separating the real part from the imaginary part. That's like the idea. All right, so whenever you're doing the word problems, and they're going to be parabolas, okay, it's mostly stuff that goes up and comes back down, which is like literally rocket science. Do you know what I'm saying? Like you're rocket scientists now. Rockets go up and come back. Have you ever heard in T minus 3 seconds, blah, blah, blah? That's what this is, okay? To find the vertex, because what you get asked a lot about is the vertex. It is negative b over 2a. So I'm not going to make you memorize this like whole big formula, but you do need to know that one. And look at where it comes from, guys. All connected. Okay. So if you want to find the center, that like axis of symmetry where the vertex is, that's your little formula. And it's the beginning of the quadratic formula, negative b over 2a. So the path of a cannonball, like it's just objects that go up and come back down. They follow parabolas. Follows this function. Do you see how it's a parabola? Do you see how it's negative? So it's like reflected. X is time in seconds. Let's circle seconds so we know what our units are. Y is height in feet. You have seconds and you have feet. Has anyone taken physics or currently taking physics? Like, yeah, feet per second and all that good stuff. All right. What is the maximum height reached by the cannonball? And when does this happen? All right, look, it's going to go up and come back down. So what you're being asked for is that vertex. So we're going to use this little formula, negative b over 2a. So negative b. What number out of this is b? Good. 32. So negative b over 2a, what number out of this is a? Negative 2. The negatives are going to cancel, which is good because we don't have negative seconds. Okay. So it'll be 32 over 4, which is 8. Now, that is the time that it happened. That's the x value. Okay. Now, if you want to know the actual height, what do you do with 8? You have to plug it in to the function. So we're going to take 8, plug it in right here. 8 squared. This might get tough, and I may pull out a calculator some. We'll see how far we can get without a calculator. 64. If you double 64, that is, but it is negative. So we have negative 128 plus, all right, 32 times 8. Let's see, 8 times 2 would be 16. You would carry a 1. 256. Thank you for, yeah, I like doing it in my head. I need confirmation. Plus 14. Let me just type that in really quick because I don't want to try and do it in my head and mess it up. If you want to try and do it in your head and get it before me. 142. Yeah, it's 142. So here's how you write your answer though. Listen. What is the maximum height? It is 142 feet at time being 8 seconds. That is why we write maximums and minimums that way. If I ask what's the maximum, you wouldn't say 8 comma 142. Like we don't talk that way. That's silly. You would say it's 142 feet. And then if I asked you when, you would go further and say, well, at time 8 seconds. Okay. When does the cannonball hit the ground? Hey guys, if it's on the ground, how many feet in the air is it? You're going to set the thing equal to 0 and pick one of the methods that we had looked at. So it is negative 2x squared plus 32x plus 14 equals 0. I just took that whole thing, set it equal to 0. Yeah, I would try to factor first because if it does factor, that's always nice. What do you notice goes into all of these? 2, and I would actually divide out negative 2. Watch what happens. It's going to make all the numbers smaller. If you can divide through by something, do it. Because if you don't have a calculator, you want the numbers little. Does that make sense? Make them smaller. So that would give you x squared minus, good, because we're dividing by a negative 2, minus 16x minus 7 equals, isn't 0 great? 0 divided by anything, 0. Now, unfortunately, this won't factor. How do I know that already? Like just from looking at it, like if you, because of the 7, it would be 7 times 1. That's never going to add up to be 16. So it will not work. So I would complete the square. You could do quadratic formula if you want, but I wouldn't. So x squared minus 16x, leave a gap, add over the 7, and then we're going to divide by 2 and square. So 16 divided by 2 would be 8 squared, 64. The whole point is you can write it as something squared. So what is the something that will go in the blank? That was a good question. When we divided it at the beginning, it was just gone. And isn't that wonderful? Let me say that again, because I always get asked that. What happened to that -2? We got rid of it, get rid of it. It's like we did that to make our lives easier. It's gone from us, all right? X minus 8 squared equals, what is that, 71? And then how do you get rid of the square? We're like almost there. Square root. Now, typically you put a plus and minus, but this is a story problem and we don't do negative seconds. So we're just going to do positive, okay? So thank you. I thought it made sense too. It'll be x minus 8 equals square root of 71. And then you would add the 8. So 8 plus square root of 71 seconds, whatever that is. What would the square root of 71 be about though? Like square root of 64 would be 8. So it'd be like a little bit more than 8. Yeah, like 8 point something. So 8 plus 8 point, it'd be around 16 point something seconds. And then, bless you, we catch a break on this one. This one's actually really easy. From what height is the cannonball launched from? Well, when you launch it, that's 0 seconds, right? Initial velocity, if you're in physics. So if you plug in 0 for x, what do you get? 14 feet. So it was launched from 14 feet. So either the cannon was on something, like, or it had like a really long cannon. I don't know anything about cannons. All right, a ball gets thrown in the air. It goes up and comes back down. Imagine a baseball or a football or a soccer ball or whatever your favorite sport is. All right, it's gonna go up and come back down. Follows this formula. Time is in seconds, height is in feet. I usually use seconds and feet, but every once in a while I'll pick like yards or something just to make sure you read the problem. So just always circle those. What is the maximum? All right, the ball goes up and comes back down. We want the center. What was that little formula I told you to get the center? Good. What is B in this scenario? 4. So -4 over 2 times A, which is -2. It's always going to turn out that they're both negative and then they cancel. You can't have negative time. So this will be 4 over 4, which is 1 second. But if you want the actual answer, what do you do with 1? Plug it back in. This will be a little bit easier to plug in. That would give us -2. If we're just plugging in 1, you'd have -2 plus 4 plus 6, 8. So it would be 8 feet at time 1 second. So you threw it and a second later it got to the peak, which was 8 feet. Not very tall. I don't know. Math word problems are silly. Maybe, yeah. When does the ball hit the ground? Hey guys, if it's on the ground, how many feet in the air is it? 0. You're going to take this whole thing, set it equal to 0. And I would, again, if you can, divide everything by -2 because it's going to make the numbers smaller, which is good. If you don't have a calculator, you want smaller numbers. Not that 6 is that big of a number, but you know, I just would do it anyway. It's too big for you. You can't count to 6. All right, so this would be t squared minus 2t minus 3 equals 0. If it factors, you want to factor because that's the easiest method. If not, then complete the square. But I think this one factors. You would split it t times t. How would 3s? 1 and 3. Good, and then do the symbols last. Do one thing at a time. To get a -2t in the middle, it would need to be -3 plus 1. So look, you get t equals what from this one? -1, which doesn't make any sense. Throw it out. Why? You're gonna do negative time, all right? So your answer is t equals 3 seconds. From what height is the ball thrown? That's initial velocity. You plug in 0, 6 feet. Yeah, right.